The National Electrical Code, or NEC, does not mandate the grounding of non-electric signs. Article 600 specifically addresses electric signs and does not extend its requirements to signs that do not utilize electricity. Therefore, the interpretation that Section 600.7 applies solely to electric signs is accurate. Regarding LED signs, the NEC doesn't explicitly outline grounding requirements for these. However, given that LED signs are powered by electricity, they can be classified as electric signs, making them subject to the grounding stipulations of Section 600.7. There are a few additional considerations to keep in mind. Firstly, local codes. Local authorities having jurisdiction or ODs have the power to enforce grounding regulations that exceed the NEC standards. Secondly, low direct current or DC voltage. The NEC in Article 600 makes no exceptions for low-voltage circuits, so the low-voltage characteristic of LED signs does not exempt them from the need for grounding. Thirdly, there is safety. Grounding is an essential safety measure, as it offers a clear path for fault currents, diverting them away from equipment and thereby minimizing the likelihood of electrical shock. As a general safety precaution, it is advisable to ground all electrical equipment, including LED signs. In conclusion, based on the NEC guidelines and established safety practices, it is recommended to ground all electric signs, which includes LED signs. Grounding is not required for non-electric signs. Nonetheless, it's important to be aware that local codes may introduce additional grounding requirements. For electric signs, understanding the NEC requirements is crucial for safety and code compliance. The NEC, specifically Article 600, dictates the standards for electric signs and outline lighting, emphasizing safety through grounding. Grounding creates a safe path for fault currents. This prevents electrical shock and reduces the risk of fire. LED signs, though operating at low voltage, are still considered electric signs and are generally subject to NEC grounding requirements. It's important to note that the absence of explicit language in the NEC regarding LED signs doesn't automatically exempt them. Local regulations and AHA interpretations often play a significant role in enforcing grounding for LED signs. To navigate these requirements effectively, electricians and installers need a clear understanding of the NEC and any supplemental local codes. Firstly, consult the NEC Article 600. It offers a comprehensive guide to electrical sign installations, including grounding. Secondly, check local amendments and regulations. Local AHA may have stricter or more detailed requirements beyond the NEC. Thirdly, consider safety best practices. Grounding all electric signs, regardless of voltage, enhances safety and minimizes risk. Understanding the purpose of grounding is crucial. It is not merely a code requirement, but a safety measure that protects people and property. By grounding electric signs, you create a low impedance path for fault currents, allowing protective devices like circuit breakers to quickly interrupt the circuit in the event of a fault. This rapid response minimizes the duration of electrical faults, reducing the risk of electrical shock, fire, and equipment damage. When installing electric signs, select appropriate grounding conductors and connectors. Use grounding conductors of adequate size and insulation rating, following NEC tables and guidelines. Ensure that all connections are clean, tight, and corrosion resistant. Proper grounding techniques, such as bonding metal parts and using grounding electrodes, are essential for effective fault current management. If you are unsure about any aspect of grounding electric signs, consult a qualified electrical engineer or inspector. They can provide guidance on specific requirements, best practices, and compliance with applicable codes and regulations. Remember that grounding is a critical safety measure and it's essential to get it right. By adhering to the NEC, local codes, and best practices, you can ensure the safe and reliable operation of electric signs. Non-electric signs, on the other hand, do not require grounding. This is because they do not carry electrical current and do not pose a risk of electrical shock. However, it is always a good idea to check with your local AHA to confirm whether there are any specific requirements for non-electric signs in your area. In summary, grounding is a critical safety measure for electric signs, including LED signs. By following the NEC local codes and best practices, you can ensure the safe and reliable operation of these signs. Non-electric signs do not require grounding, but it is always a good idea to check with your local AHJ to confirm whether there are any specific requirements for non-electric signs in your area. The requirements for grounding electric signs are found in Article 600 of the National Electrical Code. This article covers the installation of electric signs and outline lighting, and it includes specific requirements for grounding. Section 600.7 of the NEC requires that all electric signs and metal equipment of outline lighting be grounded. This requirement applies to all electric signs, regardless of their voltage or type of illumination. Grounding provides a path for fault currents to flow back to the source, which helps to protect people from electric shock and prevent fires. When grounding electric signs, it is important to follow the requirements of the NEC. The grounding conductor must be sized according to the size of the circuit conductors, and it must be connected to a grounding electrode system. The grounding electrode system must be installed in accordance with Article 250 of the NEC. In addition to the requirements of the NEC, local codes may also have additional requirements for grounding electric signs. It is important to check with your local AHJ to determine what these requirements are. LED signs are electric signs, so they are subject to the grounding requirements of the NEC and local codes. Even though LED signs operate at low voltage, they can still pose a risk of electric shock if they are not properly grounded. Grounding LED signs is important for protecting people from electric shock and preventing fires. When grounding LED signs, it is important to follow the requirements of the NEC and local codes. The grounding conductor must be sized according to the size of the circuit conductors, and it must be connected to a grounding electrode system. The grounding electrode system must be installed in accordance with Article 250 of the NEC. Non-electric signs do not require grounding. This is because they do not carry electrical current and do not pose a risk of electric shock. However, it is always a good idea to check with your local AHJ to confirm whether there are any specific requirements for non-electric signs in your area. Article 600 of the NEC covers electric signs and outline lighting. It provides requirements for the installation, wiring, and grounding of these systems. Here's a breakdown of key areas within Article 600 related to grounding. Firstly, general grounding requirements. Section 600.7 mandates that signs and metal equipment of outline lighting must be grounded. This is a fundamental safety requirement. Secondly, grounding conductor sizing. The size of the grounding conductor is determined by the overcurrent protective device in the circuit, as outlined in NEC Table 250.122. Proper sizing ensures adequate fault current capacity. Thirdly, grounding electrode system. The grounding electrode system must comply with Article 250, Part Roman 3, which covers grounding electrodes and their installation. This typically involves connecting to a grounding electrode such as a ground rod, ground ring, or metal water pipe. Fourthly, methods of grounding. Acceptable methods of grounding include the use of equipment grounding conductors run with the circuit conductors, as well as other methods outlined in Article 250. Fifthly, specific requirements for neon signs. While neon signs operate at high voltage, they still fall under the general grounding requirements of Article 600. The metal enclosures of neon transformers and electrodes must be properly grounded. Sixthly, LED signs and low voltage systems. Even though LED signs often operate at low voltage, they are still considered electric signs and are subject to the grounding requirements of Article 600. The low voltage does not exempt them from the need for grounding. Seventhly, disconnecting means. Section 600.6 requires a disconnecting means to be within sight of the sign or outline lighting system. This disconnecting means must be capable of being locked in the open position and must also disconnect the grounding conductor. The grounding requirements in Article 600 are intended to protect people and property from electrical shock and fire hazards. Grounding creates a low impedance path for fault currents, allowing overcurrent protective devices to quickly trip and energize the circuit in the event of a ground fault. This rapid response minimizes the duration of electrical faults, reducing the risk of electrical shock, fire, and equipment damage. Local AHJ may have additional requirements or interpretations of the NEC. It's always best to consult with your local AHJ to ensure compliance with all applicable codes and regulations. The NEC provides a comprehensive set of rules for grounding electric signs and outline lighting. By following these rules, you can help ensure the safe and reliable operation of these systems. Article 250 of the NEC covers grounding and bonding. It provides the general requirements for grounding electrical systems and equipment. Here's a summary of the key sections within Article 250 that are relevant to electric signs. Firstly, grounding electrode system. This section outlines the requirements for establishing a grounding electrode system, which is the foundation of the grounding system. It includes requirements for grounding electrodes such as ground rods, ground rings, and metal water pipes. Secondly, equipment grounding conductors. This section covers the requirements for equipment grounding conductors, which are used to connect the non-current carrying metal parts of equipment to the grounding electrode system. Equipment grounding conductors provide a low impedance path for fault currents, allowing overcurrent protective devices to quickly trip and energize the circuit in the event of a ground fault. Thirdly, bonding. This section covers the requirements for bonding, which is the process of connecting together all metal parts that are likely to become energized. Bonding ensures that all metal parts are at the same potential, which reduces the risk of electrical shock. Fourthly, system grounding. This section covers the requirements for grounding electrical systems, such as alternating current or AC systems and direct current or DC systems. System grounding provides a reference point for the voltage in the system, which helps to stabilize the voltage and reduce the risk of electrical shock. Fifthly, grounding methods. This section covers the acceptable methods of grounding, such as the use of grounding bushings, grounding wedges, and grounding lock nuts. Grounding methods ensure that the grounding connection is reliable and effective. Article 250 provides the general requirements for grounding and bonding electrical systems and equipment. By following these requirements, you can help ensure the safety and reliability of electrical systems. Local codes may have additional requirements or interpretations of the NEC. It's always best to consult with your local AHJ to ensure compliance with all applicable codes and regulations. Article 250.122 in the NEC provides guidance on sizing equipment grounding conductors for AC circuits. This is crucial for ensuring adequate fault current capacity and safety. Here's a breakdown of how to use Table 250.122 and the related requirements. Firstly, determine the overcurrent protective device rating. The size of the equipment grounding conductor is based on the rating of the overcurrent protective device, such as a circuit breaker or fuse, that protects the circuit. Secondly, locate the overcurrent device rating in Table 250.122. The table is organized with overcurrent device ratings and amps listed in the left-hand column. Find the RAW that corresponds to the rating of your circuit's overcurrent device. Thirdly, read across the table to find the minimum size of the equipment grounding conductor. The table provides the minimum size of the equipment grounding conductor in copper or aluminum, based on the overcurrent device rating. Fourthly, consider conductor material. Table 250.122 provides separate columns for copper and aluminum conductors. Choose the column that corresponds to the material of your equipment grounding conductor. Fifthly, note any adjustments for conductor length. In some cases, the equipment grounding conductor may need to be larger than the minimum size specified in Table 250.122. This is often the case when the conductor is long, as the impedance of the conductor can reduce its effectiveness in carrying fault current. Sixthly, be aware of exceptions. There are some exceptions to the general rules for sizing equipment grounding conductors. For example, equipment grounding conductors that are part of a cable assembly may be sized differently. Seventhly, consult with a qualified electrician or electrical engineer. If you are unsure about any aspect of sizing equipment grounding conductors, consult with a qualified electrician or electrical engineer. They can provide guidance on specific requirements and best practices. Table 250.122 provides a straightforward method for determining the minimum size of equipment grounding conductors for AC circuits. By following the steps outlined above, you can ensure that your equipment grounding conductors are properly sized for safety and performance. Remember that proper grounding is essential for protecting people and property from electrical shock and fire hazards. NEC Article 600 and 250 are important and local AHA requirements must be checked.